Hi everyone, in this video I want to talk about Microsoft Foundry Hosted Agents because once I outgrow prompt agents, I still want Foundry to host and run what I build. Most teams start with a declarative agent. We pick a model, we write instructions, we attach tools, and for a lot of scenarios that really is enough. But then I need to call a private API behind my company firewall or run custom Python logic, or maybe orchestrate a real workflow with something like LangGraph, and I realize at the end that I'm stuck in configuration. So the shift here is quite simple. I keep Foundry as the managed platform, but I bring my own code. If I think about why people get frustrated with agents, it's usually not the model. It's that the first agent they build is basically text in, text out, and the moment they need to a real business step in the middle, they can't put it anywhere. In Foundry, there are 3 agent types, and the difference really comes where does the logic live. So a prompt agent is a quick one. I create it in the Foundry portal, I pick a model, I write instructions, and I attach tools from a catalog. It's fast, but here's the limitation. The agent itself doesn't execute custom server-side logic. It sends instructions to the model, and if the model decides to call a tool, it calls one of the tools I attached. I can't inject my own code. A concrete example, say I need to call my company internal REST API to check inventory, then apply a discount rule on the compliance check, and only then respond after that. With a prompt agent, there is nowhere to run that Python or C# logic on the server. A workflow agent is still declarative, but it lets me orchestrate a series of actions of other agents using YAML-based definitions. So it's great for T-step processes, but I'm still describing and not coding. A hosted agent is the jump. I write actual code, like Python or C#, package it in a Docker container, and Foundry runs it server-side. So prompt agent is like ordering from a fixed menu, and hosted agent is like access to the kitchen. I cook what I want. But the restaurant still handles at the end the tables, bills, and health inspections. And at time of recording, this is still preview, but you need to know that billing for the managed hosting runtime is planned to start no earlier than April 1st, 2026, and it's available already in 25 Azure regions. So what is this thing really when I say hosted agent? At the core, it's my agent code inside the Docker container. I build it, I version it, and Microsoft Foundry deploys it onto managed infrastructure. I'm not managing VMs, I'm not managing Kubernetes, I'm not hand building all the hosting plumbing. I give it an image and it runs. Now, around that container sits Foundry Agent Service, and that's doing the platform work. It provisions replicas, it auto-scales, it health checks, it routes messages, and it handles a lot of enterprise security and governance pieces. It also handles identity, so the agent can authenticate to things in a consistent way. The piece that makes this click is the hosting adapter. This is a small library I add to my code, and it's really just a translation layer. It does the 3 jobs. First, it exposes my agent as an HTTP service so Foundry can call it. Second, it translates Foundry request and responses format into whatever my framework expects and back again, including streaming of responses, for instance. Third, it wires up OpenTelemetry automatically, so I get traces, metrics, and logs without building that plumbing. Without the hosting adapter, I'm building my own web server. I'm speaking the Foundry protocol by hand, and then I'm trying to bolt on observability later. With it, the wrapper is tiny, usually just a couple lines to stand up the service. It's like a universal power adapter that when I travel. My appliance has one plug shape, the hotel has a different socket, and the adapter makes them work together. One more key thing Foundry manages for me is conversation state. Foundry creates durable conversation object with unique IDs. It stores the message history, tool calls, tool outputs, and metadata across turns. I don't build any of that, it's just there. The part I care about most is I have to do that painful cloud development loop. Push, wait, realize it's broken, push again, because that kills productivity. And with hosted agents, the whole inner loop stays on my laptop. I write normal framework code first, and I only think about Foundry right after the edge. So say I'm using Microsoft Agent Framework in Python, I write a Python function that does something useful, maybe get the time, call an API, run a calculation. I decorate it with @AI_function so the model can call it like a tool. Then I create a chat agent with a model client, my instructions, and that function included as a tool. And up to this point, none of this is Foundry specific, it's just regular code. Then I add the hosting adapter, and this is where Foundry enters the picture. For Microsoft Agent Framework, it's one line from agent framework agent.run. For LangGraph, I think it's from LangGraph graph.run. And before that line, I have a framework agent. After that line, I have a HTTP service that speaks the Foundry protocol. And I can test it locally. I run my Python file, it starts a local web server, and I send it a REST request. Now I can step through my code, watch tool calls that test edge cases. No deployment needed, that's a big change. And when I'm happy, I build a Docker image with a normal Docker file. One gotcha that catches a lot of people, I must build it with platform Linux AMD 64. Foundry infrastructure is Linux AMD 64, don't forget about that. And if I'm on a Apple Silicon Mac and I forget that flag, the container might start and then crash with very confusing errors. So by the time I touch the cloud, I already know the agent logic works and I know the adapter translation works. That's a very different experience from debugging after deployment. Once I've got an image, the question becomes how do I actually get into Foundry in a repeatable way? There are two paths because teams are different. Sometimes I just want the fast lane to get everything created end to end. Other times I need CI/CD control and I want to do it all with code. The fast lane is Azure Developer CLI, AZD. The flow is basically three commands. I run AZD init using the Foundry starter template, and that scaffolds the infrastructure config. Then AZD AI agent init, and that's where I point at my code, my Docker file and my agents.yaml. And then I run AZD up, that one command provisions Azure resources, builds my container, pushes it into Azure Container Registry, and creates a hosted agent version and deployment in Foundry. So it's very smooth. At the time of recording, that AZD CLI extension is in preview, so I wouldn't use it for production. For production style automation, I use the Python SDK path. Here I push my Docker image to Azure Container Registry myself, then I have to make sure Foundry can pull it. The key permission is I give the Foundry project manage identity, the Container Registry repository reader role on that repository. Then I need a capability host. This is an account level setup that enables hosted agent infrastructure on my Foundry account. It's a one-time setup, but there is an important detail. When I create it, enable public hosting environment has to be true. If I already created a capability host without that flag, I have to delete it and recreate it. And after that, I create a version with client agent.createVersion using a hosted agent definition. That's where I specify the image URL, CPU, memory, and environment variables like Azure AI project endpoint and the model deployment name. And once it's created, it shows up in the Foundry portal. I can test it in the playground and see status like any other agent. Permission-wise, it depends what I'm doing. If I'm creating a new project, I need Azure AI owner, and if the project is already configured, I often work with reader plus Azure AI user. And also, a hosted agent gets interesting when I stop thinking it runs my code, and I start thinking it combines everything. The tool story is simple. In one conversation, a hosted agent can use my own functions and the platform tools. So I think of it in three buckets. First is my own code, and any Python or C# function I put in the container runs server side. That's where I call private APIs, apply business rules, transform data, do whatever I need. And second is Foundry built-in tools, things like code interpreter, image generation, and web search. I include those tools when I create the agent version, and then the agent can call them just like any other tool. Third is model context protocol connections. That's how I connect to remote MCP servers for external services like GitHub or SaaS APIs. In the agent definition, I reference them by connection ID, and then the agent can call out to those remote services through that MCP connection. And the power is that I can really mix all three. For example, I might use web search to get fresh info, then run my own function to apply a compliance filter, then use code interpreter to do a calculation and then respond. Now, the other big out-of-the-box benefit of hosted agent is observability. The hosting adapter sets up OpenTelemetry automatically, so I get traces, metrics, and structured logs without writing a bunch of glue code. If I deploy with AZD, application insights get wired up for me, so traces land there without me doing extra work. If I want a different backend like Datadog or Grafana, I can export to any OpenTelemetry compatible place by setting the hotel exporter endpoint environment variable. And in the Foundry portal, in the agent playground, there is a traces tab. That's where I can see a request end-to-end with the model calls, tool calls, and timings that get instrumented. That's the difference between guessing and knowing. Finally, evaluation is consistent. Hosted agents support the same evaluators as prompt agents, so coherence, relevance, groundedness, task adherence, and tool call accuracy. And once this is a real code running as a managed service, I have to operate it like a service. So I care about lifecycle, cost, and how updates work. Hosted agents have a state machine. When I create it, it exists, but it stopped. When I start it, it goes starting, then started, or it can go to failed. And when I stop it, it goes stopping, then back to stopped. This is not a configuration toggle, that's a real deployment. To start it, I use the AZ command for agent service to start the deployment, and I specify min and max replicas, and then replica choice is a real cost and latency decision. If I set minimum replica to 0, I get scale to 0, so when it's idle, there are no compute charges. The trade-off is cold start. The next request after it's scaled down will be slower while it's spin up, obviously. If I set min replica to 1 or more, I keep it warm, so latency is consistent, but I'm paying steadily. And I can adjust that anytime because changing replicas is operational tuning. That brings me to updates. There are two types. A version update is when I change the container image, CPU, or memory, environment variables, or protocol versions. That creates a new version number. It's basically a new release. And a non-version update is when I change replicas or the description or tags. That doesn't create a new version, it's just tuning how the deployment runs. For debugging, I can use the container log stream API. It gives me real-time console logs, which are my apps std out and stdr and system logs, which are container lifecycle events. They are my limits. The maximum connection duration is 10 minutes and the idle timeout is 1 minute. So I usually connect, grab what I need and reconnect. There are also preview limits I need to be aware of at the time of recording. In preview, minimum replica tops out at 2 and max replicas top out at 5. I can have up to 200 hosted agents per Foundry resource and up to 100 Foundry resources with hosted agent per subscription. And for cleanup, if I use AZD down removes the associated resources, or I can do it via the SDK, like project agent delete version, depending what level I want to remove. The last piece is how do I make this available to real users without making identity a mess. Before publishing, every unpublished hosted agent in a project runs with the project managed identity. It's system assigned and it's shared across all unpublished agents in that project. So that's defined. That's fine for development, but it means permissions are shared. If I grant that identity access to a key vault, every unpublished agent effectively has that access. So that's not what I want. Publishing changes the shape. When I publish, Foundry automatically creates an agent, application, resource, and that gives me a dedicated invocation URL that stays stable across version updates. It also provisions a distinct agent identity separate from the project identity. It registers the agent in the Microsoft Entra agent registry, and it enables endpoint access that stays consistent as I deploy the new versions. Now, here's the gotcha that breaks people. Any permission assigned to the project managed identity will not carry over. After publishing, I must reassign role-based access control permissions for the new agent identity on every Azure resource it needs. That includes Azure Container Registry, Key Vault, storage, databases, anything. If I forget, it works in dev and then it fails in production, so keep an eye on it. Maybe it will change. Stay up to date with the documentation. Publishing also opens up channels. I can share a web application preview for a quick demo. I can publish to Microsoft 365 Copilot and Teams with a no-code flow where it appears in the agent store. I get a stable REST API endpoint and I can embed it into custom applications via SDK. I think of publishing like incorporating a business. Before I operated as myself, simple, but everything is in my name. After publishing, the business has its own identity and contracts, but I still have to transfer every agreement over, nothing move automatically. So the big shift with Microsoft Foundry Hosted Agent is I stop trying to squeeze real logic into a prompt configuration, and I just run my own code as a managed service. The hosting adapter is a key bridge. It turns my framework agent into an HTTP service Foundry can deploy and observe, and I get open telemetry tools and conversation state handled for me. And when I publish, I get a stable endpoint and a dedicated identity, but I must redo role-based access control because permissions don't transfer. That's it. So as always, I hope this was useful. Till next video, take care.